Hi, welcome sa week 9 ng Basic Operating System with Networking. So ang tatalakayin natin ngayon ay tungkol sa network topology. Okay? Ano ba yung network topology na tinatawag? Okay? Network topology is the way a network is arranged, including the physical or logical description of how links and nodes are set up to relate to each other. Okay, ito yung mga connections, okay, sa network, sa computer, or computer connections, kung saan ito yung kung paano sila na-arrange, okay, including physical or logical description. So, ang pag-aaralan natin dito ngayon kung ano yung mga topology na ginagamit sa networking. Okay? So, why topology is important? Okay? Design efficient protocols. So, alam naman natin yung protocol na tinatawag na this is our sets of rules. Di ba? Then, solve inter-networking problems. So, routing, yan, resource reservation, and administration. Okay? Create accurate model for simulation. Derive estimates for topological parameters and study fault tolerance and anti-attack properties. So, the topology of a network define how the nodes of a network are connected. So ano ba yung nodes na tinatawag? Ito yung mga terminals, ito yung mga computer natin. So there are two basic categories of network topologies. Okay, a physical and the logical topology. So pag sinabi nating physical, defines how the nodes of the network are physically connected. Ito yung mismo na kung paano sila nagko-connect. Okay, nag-connect. Yan. And logical topology, how data is transmitted between nodes, kung paano naman may transfer or may transmit yung data sa ibang computer. Yan, dedicated connections between certain selected source destination pairs using the underlying physical topology. So pag sinabi nating source and destination, meron tayong two or more computers na ginagamit. Okay? The source and destination. Siyempre, kapag mayroon kang source, wala ka namang destination, so wala ring silbi, di ba? So ibig sabihin, stand-alone lang yung computer natin. In order to have an efficient system, the logical topology should be chosen such that either the average hoop distance or the packet delay or the maximum flow on any link must be minimal. Yan. Okay, so the shape of the cabling layout used to link devices is called the physical topology. Yun yung cable mismo. Okay? This refers to the layout of cabling, the location of nodes, and the interconnections between the nodes and the cabling. The physical topology of a network is determined by the capabilities of the network access devices and media, the level of control of fault tolerance desired, and the cost associated with cabling or telecommunication circuits. The logical topology, in contrast, is the way that the signal acts on the network media or the way that the data passes through the network from one device to the next without regard to the physical interconnection of the devices. A logical or network logical topology is not necessarily the same as its physical. Yan. So, we have the shapes of network topology. O ito yung mga classification of network. We have the mesh, the star, bus, ring, tree, and hybrid network. So ito yung mga classification of networks. Okay? Kung paano sila na ayos o kaya na-arrange, kung paano sila nagko-communicate, paano sila interconnect. Yan. So pag sinabi nating mesh, okay, a network setup where each computer and network device is interconnected with one another. Okay, ibig sabihin, yung physical connection nila ay connected sila sa isa't isa. Hindi gumamit ng ibang device para mag-communicate o mag-interconnect. Okay? Kundi through cable. Okay? Sa loob mismo ng computer, yan, may mga device. Okay? So yung device na sinasabi ko, other device is yung example, yung hub, yung switch, yan. So yung mesh topology hindi gumamit ng ibang device. So yung device naman sa loob ng computer, sabihin na natin na built-in. Diba? So yun yung medyo other device yun, pero hindi yun external. Okay? Allowing for most transmission to be distributed even if one of the connections go down. So ibig sabihin, kapag yung isang connection sa mesh topology ay sira, ay hindi na maapektuhan yung ibang connection. Yan. This topology is not commonly used for most computer networks as it is the default and expensive to have redundant connection to every computer. So redundant connection, yun nga sinasabi ko na every computer, lahat ng computer connected sa isa't isa. Okay? Kumbaga naulit-ulit yung connection. Okay? At saka expensive. Yan. Yung cost niya medyo expensive kasi marami tayong cable na nagagamit. Okay? However, this topology is commonly used for wireless networks. Below is a visual example of simple computer setup on a network using mesh topology. Okay? So yan yung mesh topology. Tignan nyo, lahat ng computer connected sa isang computer. Yan. Ilang computer yan? 2, 4, 6. Yan, 2, 4, 5, 6. 1, 2, 3, 4, 5. Yan. So including yung sarili niya. Yan. So connected lahat sa isang computer yung ibang computer. Ibig sabihin, yan, kahit na sabihin nga natin, kahit na masira yung isang connection, meron pa ring connection. Yan. So try nyo na i-analyze kung paano yung connection niya, yung cabling niya, kasi bakit sinabi na expensive. Yun nga yung kable. Okay? Maraming kable ang gagamitin. So kapag maraming computer yan, ibig sabihin lahat may connection. So kumbaga paulit-ulit lang. Yan. Example yan ng mesh topology. Okay? So advantages. They use dedicated links to each link can only carry its own data load. So traffic problem can be avoided. Yan. So na-avoid niya yung traffic. Okay. It is robust. If any one link get damaged, it cannot affect other. O yan. Kahit na sabi natin, tanggalin natin yung isang connection, yung isang cable. Yung ibang link, hindi naapektuhan. It gives privacy and security. Yan. Message travels along a dedicated link. So meron siyang dedicated link para makapag-travel o makapag-send ng data. Fault identification and fault isolation are easy. Yan. Yung pag-troubleshoot, medyo madali lang. Yan. Ang disadvantages naman, the amount of cabling and the number of I/O ports required are very large. Yun yung I/O port, yung nakakonect sa computer mismo, yung built-in sa computer na pwedeng insertan ng cable. Okay, since every device is connected to its device through dedicated links. The sheer bulk of wiring is larger than the available space, yan, and hardware required to connected each device is highly expensive. Yan yung cabling. And application, telephone regional office, WAN, wide area network. Yan yung mga kung saan na nagagamit yung mesh topology, yan. Telephone and WAN. Yan. Then we have also the next topology is the star topology. Yan. Another example or other classification of topology is the star topology. So each device has a dedicated point-to-point link to the central controller called hub or act as a exchange. So, yung hub, sa star topology kasi, meron tayong centralized hub na tinatawag, o pwede rin naman na switch, tawagin natin switch, pwedeng router, yan. Kasi yung mga router natin may built-in na ports, okay, for LAN. Okay? There is no direct traffic between devices. And the transmission occurred only through the central hub. Yan. So nakikita nyo yung example nito, yung drawing. Tingnan natin kung may mas malaki. Yan, wala. So dito medyo maliit nga lang yung drawing. So we have the 5 computers or 5 terminals and the hub. Okay, the center. Yan. So hindi ibig sabihin na centralized. Pag sinabi natin centralized kasi, hindi ibig sabihin na nasa gitna. Okay? Pwede naman na kahit sa long table nandun yung 5 computer, pwede naman na nasa gilid yung hub or switch. Okay? So ibig lang sabihin yan, nagagamit tayo ng hub para mag-communicate yung mga computers at makabuo ng isang network. Okay? So hindi gaya ng mesh topology na walang hub na ginagamit. Pero bakit nakakapag-communicate sila? Kasi meron silang device sa loob ng computer o yung port sa computer kung saan doon nag-connect. Okay? Doon na-insert yung mga cables. Okay? So, yan yung star topology. Okay? So usually, ito yung common na ginagamit sa network, yung LAN or yung star kasi medyo madali lang yung pag-connect o kaya pag-assemble. Okay? O paggawa. Yan. The central point may be passive, active, or intelligent. Yan. So, a passive hub simply connect the arm of a star. No signal regeneration is performed. So, ibig sabihin, medyo mabagal yung connection pag ganon. Okay? An active hub is like a passive hub except that it regenerates signal. Yan, medyo mas pag sinabi kasi ng regenerate, so ibig sabihin kapag medyo hihina na, yun, nag-regenerate para mai-transfer o mai-transmit ng maayos. Okay? Intelligent hub not only regenerate signal but also perform activities such as intelligent path selection and network management. Yan. So, hindi lang siya passive, hindi lang siya active, kundi it also select network path. Yan. Yung dadaanan niya, kumbaga, pipiliin niya o kaya i-route niya, mga ganon. And network management. Yan. Ito yung example ng star topology. Okay? So we have the hub and 2, 4, 6, 8 terminals connected sa isang hub. Okay? Iisang switch. Yan. So kagaya rin ng ng mesh topology na kahit na sabi natin na nasira yung isang terminal, hindi naapektuhan yung ibang terminal. So ibig sabihin meron pa rin silang communication. Connected pa rin sila sa network kahit nawala yung isa. Yan. So mamaya discuss natin kung may mga topology man na kapag na disconnect yung isa ay mawawalan na lahat ng signal. Okay? So dito tayo sa advantages. Advantages of star topology. Okay, number 1, less expensive than mesh since each device is connected only to the hub. Okay. Installation and configuration are easy. Yan. Less cabling is needed than mesh. Robustness. If one link fails, only that link is affected, all other links remain active. Yan yung sinabi ko kanina. Easy to fault identification and to remove parts. Yan. Of course, kasi may kanya-kanyang cable, may sariling cable yung isa't isa. Okay? So, disadvantages, even it requires less cabling than mesh when compared with other topologies, it's still large, yan, ring or bus. Dependency, whole dependent on one single point. When it goes down, the whole system is dead. Yan. Yung disadvantage. Pag nasira yung hub, yun yung yung lahat ng system, lahat ng terminals ay mawawalan ng connection. Yan. So, wala tayong doon, kundi pag nasira, of course, palitan. Yan. O kaya i-troubleshoot o kaya i-repair. Okay. Yun yung disadvantage ng star topology since centralized yung connection. Kapag nasira yung access point o kaya yung tawag doon, yung hub or single point, yun, mawawalan ng connection. Then applications naman, star topology use in local area networks. High-speed LAN often use stars. So pwede rin natin i-connect yan sa WAN or wide area network. Okay? Problems, all communication pass through the central computer and the communications in the network will stop if the host computer stops functioning. Yan. Anong ibig sabihin nun? So kapag, example, kapag nag-send ka ng data sa isang terminal at nag-malfunction yung source mo, mawawalan yun ng connection. Okay? Automatic yun. Pag yung host mo ay malfunction, the network stop functioning. Okay? Then we have the bus topology. Okay. A bus topology is multi-point. Bakit sinabing multi-point? Kasi sabihin na natin na mayroon silang terminal o kaya mayroon siyang tinatawag na backbone. Yan. Here are long cable act as a backbone to link all the devices are connected to the backbone by drop lines and tabs. Yan. Pag sinabi natin drop line is the connection, the device, and the cable. The connection of the device and the cable. Okay, and the top is the splitter that cut the main link. Yan. This allows only one device to transmit at a time. Yan. Single cables connect all networks nodes without intervening connectivity devices. Devices share responsibility for getting data from one point to another. So since meron tayong tinatawag na backbone o kaya yung pinaka 'di ba sa tao yung main na tawag doon na buto natin ay yung spinal cord. Ito yung tinatawag na backbone. Okay, sa likod natin. Ganon din sa bus topology. Kung saan yung backbone, ito yung pinaka-importanting cable na ginagamit sa bus topology. Kung saan doon lang dumadaan yung data. Okay? Pabalik-balik. Yan. So, when a device sends a message, it is broadcast down on the cable in both direction. Yan. Example, sa computer 1 natin, sabihin natin dito yung computer 1 to computer 4. Lahat yan dito dadaan sa pinaka-backbone niya. Yan. Main cable sa baba. Okay. So, ganun yung bus topology. Pag nag-send ng data, lahat ng terminal, lahat ng nodes ay binabasa niya. Yan. All devices on the cable constantly monitor 4 messages meant to them. Okay. When a device detects a message meant for it, it reads the message from the cable and the other device will ignore it. Yan. Since all devices are sharing the same cable, some form of control is needed to make sure which device will transmit when otherwise there will be a collision. Okay, kapag yung dalawang computer or dalawang terminal ay sabay na nag-transmit ng data, ang mangyayari diyan is magkakaroon ng data collision. Okay, traffic. Magkakaroon ng traffic. So, ibig sabihin, mawawala o yung network, yung connection or yung pag-transfer ng data ay parang disable niya. Okay? Kaya, ibig sabihin nun, ang pag-transfer ng data sa bus topology ay minsan lang or one at a time. Okay? Kung sino yung nauna, yun muna ang bibigyan niya ng permission. Pero kapag sabay yun, di-disable niya. Oops, hindi pwede. Okay? Ibig sabihin, atras ka muna. Kasi isa lang yung dadaanan natin. Yan. Atras ka muna, then hanap tayo ng parang sa sasakyan din sa kung one way, di ba? Hanap tayo ng ibang time. Okay? Or timing para mag-send ng data. Okay? So, bawal na mag-send ng data ng sabay sa bus topology. Yan. So ganyan lang yung yung pag-send ng data. Example, ito yung sender natin. Yan, kita nyo sa video o dito sa presentation, we have the sender and the receiver. So ibig sabihin, assuming na yung sender natin is the computer A and computer D naman yung receiver natin. So makikita niyo yung arrow. So lumabas sa computer papunta sa backbone. Yan. Lahat dito sa cable, yan, lahat ng connected sa cable, babasahin niya. Okay, i-scan niya. Kahit nasa walang ano, pero dito sa dulo niya, meron tayong terminator. Ibig sabihin, pag may terminator yan, kapag nabasa ng network, babalik yung data. Babalik yung data, then papunta sa ibang terminal. Yan. So, ngayon, kung yung receiving node naman or receiving terminal ay yun yung nakabasa ng network o doon nabasa ng network yung signal kung na nagre-request siya ng ano ng data, doon niya i-send yung data. Okay? At yung other terminal naman, i-ignore na niya yan. Okay? So, ganun yung bus topology. Medyo mabagal nga lang. At yan, prone siya ng traffic. Kasi hindi pwedeng magsabay na mag-send ng data. Yan. So, yung connection yan, parang straight line lang siya. Di ba? Parang straight line lang yung connection ng bus topology kung saan magkakaroon lang ng terminal sa linya. Okay? So, kumbaga, ikakat lang yan dito. So, meron tayong T-connector dito. Then, doon may connect yung isang terminal, another T-connector, second computer, and so on. Okay? So, meron lang siyang dedicated cable or common bus cable kung saan doon lang na dumadaan yung data at binabasa niya yung mga terminal. Yan. So we have the advantages. Okay, ease of installation, less cabling and less expensive. Okay, siyempre pag less cabling, less expensive yan. Kasi ang ginagamit lang naman yung LAN, meron naman tayong built-in na LAN, di ba? Lahat naman ng computer meron siyang network interface card, di ba? Kung saan na-insert yung mga cables natin, yung RJ45. So, ang ano lang natin ay yung cable. Okay, yung cable, since meron siyang dedicated cable na usually yung tawag dito, yung cable yan is coaxial cable. Yeah? Commonly na yun, or standard na ginagamit yun. Coaxial cable, yung parang sa cable ng television natin. Okay? So madali lang install yan. Pero ang disadvantage naman is difficult reconfiguration and fault isolation. Yan. Difficult to add new device. Yan. Kasi kung ano, syempre magdadagdag ka ng kable kung mag-add ka rin ng other device. Although meron namang T-connector, puputulin lang. Pero kung minsan medyo mahirap din. Signal reflection at top can degradation in quality. Yan. Of course, kapag nag-add tayo ng device, yung signal din niya ay na bumababa rin. Okay? Yung speed, kumbaga. If any fault in backbone can stop all transmission. Yan, ito yung sinasabi ko na topology kung saan kapag yung isang pag na disconnect o kaya na sira yung backbone, yung link niya, lahat na na mawawalan ng transmission. So ganoon din sa sa star, 'di ba? Kapag nasira yung hub, mag-stop din yung transmission. Mawawala yung network. And application, most computer motherboards. So yan, lahat supported yan ng ng computer. Kasi yun nga, meron siyang connector or LAN port na tinatawag. Lahat ng computer may LAN port. Yan. Kung saan kinoconnect yung RJ45 para sa cabling natin. Okay. And the problem, the main disadvantage is bad connection to the cable can bring down the entire network. Okay. Another problem, collision occurs when two nodes send message simultaneously. Yan. May dalawang nag-send ng message simultaneously. Then we have also the ring topology. Okay, ito yung yung parang loop lang siya. Okay, walang kumbaga walang hanggan. Okay, naglo-loop lang siya, ring, parang ring. Here, each device has a dedicated connection with two devices on either side. So, yung isang terminal or isang device ay meron siyang dalawang connection. Okay? Both side, left and right. Okay? The signal is passed in one direction from device to device until it reaches the destination in each device hub repeater. Okay? When one device receives signal instead of intended, another device, each repeater then regenerates the data and passes them along. To add or delete a device requires changing only two connection. Yan. Okay. Sa ring topology naman, since naka-design siya sa ring, yan, ganyan. So ito yung cable. Ito yung cable yung parang ring na yan. So each device naman, each computer connected to the ring. Okay? Yan. So meron tayong tinatawag na token ring. Token ring kung saan yun yung kung ito yung example yung trend natin, yung LRT or kaya MRT natin sa Manila. Example 'yon. 'Di ba dumadaan siya sa relays, no? So yung relays na 'yon, ito yung ring. Okay? Yun yung pathway niya. Ngayon yung token ring na tinatawag, yun yung trend. 'Di ba? Yung relays, yun yung ring. Yung token ring, yun yung trend. Ngayon, yung trend or yung token ring, siya yung nagdadala ng mga data. Okay, yung data, ito yung mga tao. Pero bago yan, meron pa silang pagdadaanan. Okay, gaya lang sa trend, pagpasok mo o kaya pag akyat mo sa terminal, sa station, okay, 'di ba kukuha ka pa ng beep card na tinatawag. Now, ngayon sa data hindi pa buo. Kumbaga hindi pa pwedeng i-send yung isang data kapag wala pa siyang beep card. Example, sa trend, di ba? Hindi pa buo yung data, hindi ka pa pwedeng mai-transmit kung hindi ka pa kung wala ka pang permission. Di ba? Of course, sa terminal ng trend may mga guards. Kaya hindi ka naman pwedeng makapasok sa loob ng terminal kasi meron tayong tinatawag na beep card at meron ding gate. Kaya hindi ka makakapasok doon kung wala kang beep card. Kasi yun yung permission mo o kaya parang yun yung token mo para makapasok sa station. sa loob mismo para makasakay. Ngayon kapag nakabili ka na o kaya nakakuha ka na ng card, ng beep card, doon ka lang mabibigyan ng permission na makapasok sa loob ng terminal o kaya sa loob ng tren. Ibig sabihin, kapag nakapasok ka na, buo na yung data, buo na yung yung information para ma-transmit. Di ba? Para ma-transfer. So pagpasok mo ng pagpasok sa loob ng tren, 'yon. Ngayon, yung beep card mo na 'yon ay yun yung kumbaga address. Yung pinaka-address mo kung saan ma-send yung data na 'yon. Okay? Example sa Terminal 1, Terminal 2, Terminal 3. Kung yung beep card mo ay sa Terminal 3, from Terminal 1 to Terminal 3, doon lang pwede bababa. Doon lang pwedeng mai-send yung data. Diba? So ganun din sa ibang ganun din sa token ring. Kung sino yung nag-request, of course sa train kasi ikaw yung magre-request na data. Okay? Ikaw kukuha ka ng beep card, yun na yung address, yun na yung data mo. Pinaka-address mo kung saan ka bababa. Okay? So sa token ring ganun, kung sino yung nag-request ng transmission, doon hihinto yung token ring. Okay? Kasi yung token ring na yun or yung token ay siya yung tagadala ng data. Okay? Gaya rin sa trend, may ikot lang naman yan sa relays, di ba? Dalawa yung pathway niya, may ikot lang yun. Walang walang umiikot o kaya pabalik-balik lang. Sabihin na natin umiikot. Kasi kapag nadanon niya yung naabot niya yung end niya, iikot din 'yan. Okay? Para lilipat sa kabilang relays. Okay, 'di ba dalawa yung relays sa terminal. So pag ganun yung nangyari, sa kabila naman siya dadaan. Yan. Paikot-ikot lang yung thread. Ganon din sa token ring. Iisang direction lang, hindi naman pwedeng babalik yan sa network. Of course, sa trend pwede. Pero yung pag-transfer ng data, yun yung example natin. Kung paano mag-transfer ng data yung token ring at saka yung trend. So, yung computer natin, yun yung mga terminals. Yan, yung mga terminals. Kung clockwise yung pag-ikot ng trend, ng token, ganun lang siya. Hindi pwedeng babalik. Okay? Isa lang. So, kapag nag-send yung isa, yun nga, one at a time din yung pag-send ng data. Kasi isa lang yung trend o isa lang yung token. So, kung sino yung naunang nag-request ng token, doon mapupunta yung token at doon magkukuha ng data. At kung sino yung receiving terminal, yan, since babasahin niya yan, dadaan siya dyan sa mga terminals na yan, then kung sino yung receiving signal, doon niya dadalhin. Yan, may ikot lang yung token dyan. Then pag nadaanan niya yung receiving terminal, yon, doon siya hihinto. Then pag nadaan na niya at naibaba na niya yung data at may nag-request na naman, dadaan siya. Okay? Ganun pa rin yung direction. Okay? Kung ito, example, ito yung nag-request, dadaan siya. Yan. Sa loop. Okay? So, ganun yung token ring or ring topology. Okay? So, imagine niyo kung paano mag-send ng o magdala ng passenger yung tren, ganun din yung ring topology. So, hindi naman basta-basta may-send yung data. So, of course, may mga dadaanan pa rin siya para mabuo siya, gaya rin ng sa train station. Kailangan na kukuha ka pa rin ng permission para makapagbiyahe, mga ganon. O permit. Yung permit natin, yun yung token o yung beep card. Okay? So advantages, easy to install and easy to reconfigure, and fault identification is easy. Pero yung advantage niya, or unidirectional traffic. Yan. And break a single ring can break entire network. Yon yung natin. Pag nasira yung loop, na basag o kaya na putol yung loop, lahat ng network ay mawawalan ng connection. Kasi yung cable na ginagamit dito is fiber optic na tinatawag. Yun yung mostly na ginagamit kasi mas mabilis kasi yun. Kasi yung fiber optic cable, yun yung kumbaga glass. Okay, light yung dumadaan sa cable. Hindi gaya ng ng UTP natin ng coaxial kuryente. Although sa fiber optic may kuryente pero light. Okay, sabihin na natin na yung light, try natin yung flashlight na pag switch mo nandun na agad yung ilaw niya. Okay? So ganun din sa ring topology sa fiber optic. Okay? So application ring topologies are found in some office buildings or school campuses. Today high-speed LANs made this topology less popular. Yan. And we have also the tree topology. Okay, tree. Ito yung tinatawag na tawag na doon sa parang yung mga hub, yung mga switch ay may connection. Okay, segment. Yan. May mga segment. Alternatively referred to as a star bus topology. Okay? Kumbaga mix. Okay? Tree topology is one of the most common network setup that is similar to bus topology and star topology. A tree topology connects multiple star networks to other star networks. Okay? So ito yung example niya. Okay? May connection sa ibang computers. Yun nga sa connection tawag doon yung combination of bus and star topology. Okay? So yan. And the hybrid topology, a network which contains all type of physical structure and connected under a single backbone channel. Yan. So yan yung segment, may mga segment. Okay? Meron siyang backbone din na parang LAN pero mayroon siyang sariling network. Okay? May iba't ibang network siya, segment network. Yan. So, meron siyang ginagamit na pinaka-backbone cable or channel. Okay? That is hybrid topology. So, pwede mo nang i-connect sa sa merong LAN or star, ring, yan, sa pwedeng bus, pwedeng pwedeng mesh topology. So combination mismo ng lahat ng topology. Okay? Considerations for choosing topology. Okay, money, length, future growth, and cable type. So, yan. Full mesh topology is theoretically the best since every device is connected to every other device. And those maximizing speed and security, however, quite expensive to install. Yeah. Next best would be the tree topology, which is basically a connection of star and bus. Okay. And the backbone network, serial backbone, yan, DC chain, yan, link series of devices, hubs and switches often connected in DC chain to extend a network. So yung ginagamit natin sa school natin, sa laboratory is DC chain, tinatawag. Each hub or switch are often connected, okay, to extend a network. Yan. Kapag mag-extend tayo kasi maraming terminal, hindi kaya ng hub o switch, eh, kung may 8 port lang yung switch o kaya 16 port or 24 ports, at pag more than yung computer natin, okay, more than 24, ibig sabihin, gagamit tayo ng another switch or hub para ma-extend yung network. Yan. Hubs, gateways, routers, switches, and bridges can form part of backbone, and extent to which hub can be connected is limited. Yan. So, okay, so dyan nagtatapos yung discussion natin about network topology. So, I hope na naintindihan nyo na kung bakit kukonect tayo sa network. Okay? Kung ano ba yung topology na tinatawag, bakit may mga classification pa, bakit pinipili natin yung star, bakit pinipili natin yung mesh topology, kasi may mga dahilan yan. Okay, yun nga yung advantages, okay, depende yun sa pangangailangan ng isang kumpanya. Okay, so yung pagpili sa topology. Okay, so sa natin, sa module natin, meron tayong activity. Okay, so yun, sagutin nyo lang yun. Hope na naintindihan nyo naman, basahin nyo lang yan. Nandyan yung mga sagot sa mga activity natin. At meron din tayong mga actual activity na tinatawag. Okay, so i-perform nyo lang yun since gagamit kayo ng mga recycled materials, no? Para ma-perform yun. Okay, so example, yung pag-create kayo ng topology ng network using cartoons, styro, mga ganon. So, yun. Okay, so hanggang dito na lang at maraming salamat sa sa pakikinig. Okay, pakikinig sa pag-join natin sa group natin. Okay, so yan. Okay? So ingat lang. And good luck.